In this presentations, we are going to discuss about main memory in operating system. So the objective is to provide a detailed descriptions of various way of organizing memory hardware. So the background for this topic is program must be brought into a memory and placed within a process for it to be run. So main memory and registers are only storage CPU can access directly. So the memory unit only sees a streams of address plus read request or address plus data and write request. So the register access is done in one CPU clock. So the main memory can take many cycles causing a stall. So the cat sits between main memory and the CPU registers. So it protections of memory record to ensure corrected operations. So in this protections, we need to ensure that the process can access only those address in its address space. So we can provide this protections by using a pair of base and limit registers define the logical address space of a process. In the hardware address protections, CPU must check every memory access generated in user mode to be sure it is between base and limit of that user. So the CPU generated address is compared with the comparisons to the base address. If it isn't satisfied the conditions, it's then check the another conditions with the base and limited address. Afterwards the data is to be stored into the memory. So the instructions to loading the base and limit registers are privileged. So the address binding programs on disk ready to be brought into memory to execute from an input queue without support must be loaded into address 0. So the inconvenience to have the first upper process physical address always at 0. So how can it not be address representations in different ways at a different stage of a program life. The source code address usually symbolic. Compiled code address bind to relocatable address. So that is 14 byte from the beginning of this model. So the linker and loader will bind relocatable address to the absolute address. That is an 74014. So each binding maps one address space to another. So binding of instructions and data to memory. So address binding of instructions and data to memory address can happen at 3 different stages: compile time, load time, execution time. If the memory locations known at priority, absolute code can be generated. Must recompile code if starting location changes. In this load time must generate relocatable code if the memory locations is not known at the compile time. In the execution time binding delays until runtime if the process can be moved during executions from one memory segment to another. So in this multi-step processing of user program, initially the source program is compiled or assembled. That's then the higher level language is converted into user understandable language. So that is in the object code, that is in the object model. Okay. So afterwards some linkage editors to perform the needed files to be linked. Finally it is loaded by using the loader. So with the help of the system libraries, it can be loaded into the memory. So with memory binary data are stored into the memory. So these are the stages. So in this logical versus physical address space, there are two kind of address are used when the data are processed and stored into the memory. So logical address and physical address. So before that, words in space. The concept of the logical address is space that is bounded to a separate physical address space is general to proper memory management. The logical address is generated by the CPU, also referred to as virtual address. The physical address seen by the memory unit. The logical and physical address are the same in the compilation time and load time. The logical address and physical address are differ in the execution time. So the logical address space is the set of logical addresses generated by a program. The physical address space is a set of all physical address generated by a program. So in this memory management unit, the hardware device that at runtime map virtual to physical address. Initially the CPU generated logical address. So that is converted to a physical address by using the memory management unit. After the physical address calculations only we can store into the memory. So in this, consider a simple scheme which is generalized of the base register scheme. The base register is now called relocation register. The value is the relocation register is added to every address generated by the user process at the time it is sent to memory. Actually, initially the CPU generate a logical address, then in the processing time the memory unit afterwards generate a relocation address. So the logical address is added with the relocation address, finally we get the physical address. So that is the indications of the memory bar to be loaded. Then the dynamic loading. So the entire program does need to be in memory to execute. So routine is not loaded until it is called. So better memory space utilizations. Unused routine is never loaded. So all routines kept on disk in relocatable load format. So useful when large amount of codes are needed to handle infrequently occurring tasks. So no special support from the operating systems is required. So implemented through the program designs or OS can help by providing libraries to implement the dynamic loading. In this dynamic linking, it is static linking where the system's libraries and program codes combine whatever required for the executions or the program process completions. It can't link from the libraries and some set of stubs, etc. So this stubs replace itself with the address of the routine and executes the routines. Operating system checks if the routine is in process memory address. If not in address space, add the address space. Dynamic linking is particularly useful for the libraries. Systems are also known as shared libraries. Okay, thank you.